Hello everyone and welcome to our slideshow presentation. I'm going to walk you through slides here for Maths 5, the first of the Maths 5 ones that we've been doing, and this is for non-homogeneous second order ODEs. Now, up till now you've done homogeneous second order ODEs, which means that the right hand side is 0, and I expect you to have done all of the work on this before you even attempt this bit here. So what is a non-homogeneous ODE and how do you solve it? Well, let's just find out. Let's just get into this straight away. So as you can see, that's not me. We don't have a board as big as that at City of Glasgow College. So non-homogeneous means that the right-hand side is no longer 0. So in this case, we've got y double dash plus y dash minus 2y equals 2t plus 1. Normally, we would have y double dash plus y dash minus 2y is 0. And that's the homogeneous type, which you already know how to solve. But you don't know how to solve if it's 2t plus 1. Usually if there's something on the right-hand side, it means in the real world that it's being forced. There's a function that's forcing it. So how do you solve it? Well, there's 3 stages overall to solving it. The first stage is to forget that the right-hand side isn't 0. Just make it 0. And basically solve the homogeneous equation. And that'll give you the complementary function, as we call it. The complementary function is something you should already be able to do. In this case, it would be y is ae to the t plus be to the negative 2t. And as we say here, you already know how to do this. So stage 2 is to find any solution whatsoever to y double dash plus y dash minus 2y equals 2t plus 1. Okay, now that is called the particular integral. It's a strange name, but that's what it's called. And I use yp to denote it. So how do you find that? Well, that's really what this whole show is about. So stage 3 is to put these two things together. So we've got the particular integral, which is the new techniques you're going to learn here, but we've got the old ones, which is the complementary function, the homogeneous. So you just put them together, you just add them together, and that gives you the general solution of the full thing. Okay, so let's go on and just start this with a non-homogeneous. So how do you find a particular integral? Now, there's a lot of blurb here. Okay, to find your particular integral, what we rely on is the fact that when you differentiate and double differentiate, the form of a function usually isn't changed. So if I start with a polynomial and I differentiate it, it becomes, it's still a polynomial. And if I was to double differentiate that one, it would just be 6t plus 2, which again would still technically be a polynomial. If I start with an exponential and differentiate an exponential, you get another exponential. If I differentiate it again, I get another exponential. So the idea is that with these type of equations that we're giving you, which are we call them constant coefficient second order ODEs, basically the only thing that happens is you differentiate your function. So if differentiating doesn't change the form of the function, then when you differentiate it, you again don't change the form of the function. Okay, so therefore what we're really saying there is, that's a long way of saying, that if this side here, all right, if the right hand side, in our case 2t plus 1, if the right hand side is a linear function, right, then we must start with a linear function as our particular integral, because if you differentiate it, it won't change the form of that. Okay. On the other hand, if the right hand side is a quadratic, then we're going to start with a quadratic as a particular integral. If the right hand side is a exponential, we're going to start with an exponential as our particular integral. So we're going to try and match the type of functions. So I've got a little quite large table here to show you. And basically the table is just saying that if we've got, say, just what I said earlier, if we've got a linear function there, so the function on the right is a linear function, then the trial function, the one that we're going to have for a particular integral, is going to be this one. And basically what we have to do is to find out the coefficients C1 and C0. Okay, we've got to determine what they are. If it was a polynomial, for example, a2t squared plus a1t plus a0, or a3t cubed plus a2t squared plus a1t plus a0, then we would start with the same trial function. Okay, so if we start with this quadratic on the right, our trial function is going to be a quadratic. And what we have to do is we have to try and determine these coefficients, C2, C1, and C0. Incidentally, if you notice here, these numbers here, like the 2, okay, at the bottom matches the power at the top. Okay, so 2, 2, 1, 1. You don't see the 1 here, but it is. And 0, 0, like t to the 0 is 1. An exponential function, that's actually nice and easy. So if we've got an exponential function on the right hand side here, then the trail function should be another exponential. It'll have the same power term, but we don't know what the coefficient is going to be. It won't be the same coefficient. And the trig function is the sort of odd one out. If you've got a trig function, for example, the sine, then the trail function is actually going to be a mix of sine and cosine. There's a reason for that. We'll get into that a wee bit later on, but not in this particular video. So basically, again, we've got to determine these coefficients. So this is called the method of undetermined coefficients. So just to give you an idea then from a table. So if I have this table here, for example, so what we've got is that we've got, if the right-hand side was 3t plus 2, for example, then our trail function, that's a linear function, so our trail function would be c1t plus c0. If the right-hand side is a quadratic, like 8t squared minus 3t plus 6, our trail function is going to be another quadratic. And you have to determine c2, c1, and c0. If it's a cubic, then the trail function is a cubic. Incidentally, this one here, if you notice that there's no square term, but in the original function, but in the trail function you have to include a square term because you don't know that there's no square term in the trail function. The right-hand side, if it was an exponential, then the trail function would be an exponential, okay, of the same power. So e to the 4t, e to the 4t. The only thing that's different is the coefficient c. So you have to find the coefficient. And again, with this one, negative 2e to negative 3t, then you would just try ce to negative 3t. You have to find c. And if we had something like this, 2 sine 5t on the right-hand side of the differential equation, then the trail function would be a mix of sine and cosines. Incidentally, notice that we've got sine 5t and cos 5t. But again, you just need to find the coefficients. So let's do one. So to do that, what we need is a 5-step procedure. So the 5-step procedure to do the first example is going to be, first of all, when we see the example, we're going to say what form is the right-hand side. Then we're going to say, okay, let's just choose a trail function of that form. If it's linear, we'll use a linear function. Number 3 is we need to fit it to differential equations. So we need to differentiate and double differentiate it. Number 4, once we've done that, we can then substitute it back into the original equation we were given. And once we've done that, we can equate like terms, and this is so we can find the coefficients. And that's basically us finished. So let's try one. So let's solve y double dash plus y dashed minus 2y is 2t plus 1 is t plus 1. So the first stage is to solve that equation there, which is the homogeneous equation. And this gives the complementary solution, and it turns out to be that. So I hope you can do that. That turns out to be dead easy. So you now need a particular integral. So notice that the right-hand side is linear. So therefore, we're going to choose a linear function for our particular integral. Okay. So it's going to be yp is going to be c1t plus c0. So now we need to calculate the derivatives. This is really easy. So the derivative of this is going to be c1, and the double derivative is going to be 0. So we'll put these back in the original equation. Right, so this is the original equation here. So d2y by dt squared is we know is 0. dy by dt is going to be c1, and y we know is going to be c1t plus c0. So if we put them back into the original equation, we get that. And I've just tidied it up by removing the 0 just at the start. And we get negative c1 minus 2 lots of c1t plus c0 equals t plus 1. And all we have to do is find out c1 and c0. And we do that just by equating coefficients. Let me show you how to do it. So we've got here, excuse me, we've got minus, this is what we originally had, minus c1 minus 2 lots of that, it's t plus 1. So you multiply the brackets first. And then I've just color-coded these to help you out. So I've color-coded anything with a T in it as yellow and anything else is red. So you equate the light terms, so equate the yellow terms. So negative 2c1t is t, so negative 2c1 must be 1. And the other terms, the red terms, is negative c1 minus 2c0, and we know that that must be 1. So solving that then, the first equation is negative 2c1 is 1, so c1 is negative a half. And if you substitute that in the other equation, which the other equation is negative c1 minus 2c0 is 1, that's the other equation, you will get that c0 is negative 3/4. So we know that our full function is y equals, particular integral is going to be yp equals c1t plus c0. So it's going to be negative a half t minus 3/4. And that's our particular integral. Loads and loads of juicy marks. Then the full general solution, we have to put that together. So the full general solution is y equals ae to the t plus be to the negative t. Remember, that came from the homogeneous part, that's the complementary function. And then the next bit is the particular integral minus a half t minus 3/4. That's the general solution. It's called general because it's still got a and b in it. All right, so down here, let's remember there's still an a and a b, so it's still a general solution to the full thing. And that's it. That's how we do it. Let's do another one. So let's do y double dash minus 2y dash minus 3y is 16 minus 5. Again, we use the complementary function, so in other words, y double dash minus 2y dash minus 3y is 0, right? And that gives y is ae to the negative t plus be to the 3t. So the right hand side is a linear term, so we guess that linear particular integral, differentiate, double differentiate, and substitute these and back into the original equation. Y double dash minus 2y dash minus 3y is 16 minus 5. And so we get that. And I've tidied it up to get negative 3c1t minus 2c1 minus 3c0 equals 16 minus 5. So again, we're just going to equate the coefficients. So the negative 3c1t has got to equate to 6t. So therefore, negative 3c1 must be 6, so c1 must be negative 2. The other bit, the red bit, negative 2c1 minus 3c0 must be the negative 5. So if you solve it, you get c1 is negative 2 and c0 is 3. So the particular integral is going to be negative 2t plus 3. So the general solution, again it's general because it's getting a and a b in it, is your complementary function, ae to negative t plus be to 3t, and your particular integral, negative 2t plus 3. That's it. So I want you to try that. That's an example. Again, you don't have to try it right now. I'm just talking you through this slideshow. You can try this at your leisure. All these slides are up on My City, and you can go through them at your leisure. So what's the next step? There's only one more step in this video here, and that is finding particular solutions. So notice that I've said that so far we've still got a and b in our solution. So that means that these are still general solutions. So how would you find a particular solution? Okay, so we're going to finish by showing you two examples of doing that. So supposing we have this one, y double dash minus 2y dash minus 3y is 6t minus 5. And given that the general solution is y equals ae to the t plus be to the negative 2t minus 2t plus 3, that's the general solution. You've got to find the particular solution for which y0 is 3 and dy by dt y dash is 2. Okay, so to do that, we're not really going to do anything clever here, right? All we're going to do is we're going to take that and substitute and basically match it to these values. All right, it's really quite straightforward. So let's do it. So the first one is y equals ae to the negative t plus be to 3t minus 2t plus b. So let's put t is 0 in there. And if you do that, get that. And because e to the negative 0 and e to the 0 are both 1 and 2 nothings are nothing, it becomes a plus b plus 3. Now, originally y0 was 3, if you look at the big green 3 there. So therefore, a plus b plus 3 must be 3. Therefore, a plus b is 0. That's the first of our equations. Now, of course, that means that a is the negative of b. All right, so if b is 12, a would be negative 12, and so forth. Okay, but anyway, that's just the first of the two equations. Let's find the other one. To find the other one, we need to find dy by dt. So, dy by dt turns out to be that. And if you set t as 0, you get this, and therefore that. But that's equal to the big green 2. So therefore, taking the negative 2 to the other side, you get negative a plus 3b is 4. That's the second of our two equations. So what we've got is two equations there. A plus b is 0 and negative a plus 3b is 4. That's these two. So solving that, you would get that a is negative 1 and b is 1. All right. I mean, so for here you get that b is negative a. So negative a is b. So b plus 3b is 4b. and that equals 4, so therefore b must be 1, right? Okay, or just basically add these two together. If you add the two equations, a plus negative a is 0, b plus 3b is 4b, 0 plus 4 is 4, so 4b is 4, so b is 1. Okay, so the full particular solution is therefore negative as a e to the negative t plus b e to the 3t, but we know that a and b are negative 1 and 1, so it's going to be negative e to the negative t plus e to the 3t minus 2t plus 3. Lots of marks. Let me show you the last one. So this one, y double dash plus y, now this one looks harder, but it's not. Y double dash plus y dash minus 2y is t plus 1. The general solution is this beast here. Y is a e to the t plus b e to the negative 2t minus a half t minus 3/4. So find the particular solution for which y0 is 8.25 and y dashed is 2.5. Oh no, right? Turns out to be easy. Okay, so let's work out how to do it. So first of all, we'll start with y and dy by dt. So you just differentiate y to get dy by dt. So if you put y0 in, you get a plus a e to the 0 plus b e to the negative 0 minus a half times 0 minus 3/4, and that works out to be a plus b minus 3/4. And we're given that that's 8.25. That's what that bit says. So if you take the negative 3/4 over to this side, you get a plus b is 9. Let's look at the derivative. So the derivative is a e to the 0 minus 2b e to the minus 20 minus a half. So that becomes a minus 2b minus a half. And that is equal to 2.5. We take this negative a half to the other side where it becomes 3. So a minus 2b is 3. So if you solve these two equations, a plus b is 9 and a minus 2b is 3, you'll get that a is 7, b is 2. So our full solution is a e to the t plus b e to the negative 2t minus a half t minus 3/4, but in our case it becomes 7e to the t plus 2e to the negative t minus a half t minus 3/4. And again, lots of marks for that. And there's one here for you to try on your own. Again, you don't have to quickly note this down. I'm just quickly talking through the slides, and you'll find this online at my city. So next steps then, I may put videos up for these or may not, depending on what you want. So you should now be able to do non-homogeneous functions with linear terms on the right. That's a very, very common exam question. So the next step will be, the second set of slides will show you how to handle a polynomial on the right. We'll only show quadratic. The third set of slides will show you how to solve it if the right hand side is an exponential form. That's a really, really, really common exam question as well. Then the final set of slides isn't so common as an exam question. It's when you handle sines or cosines on the right. And this is more for university engineering applications, but please look at it anyway to prepare yourself, because it's a very common case at university where there's the forcing function is a sine. Okay, so it's important that you know it. So that's basically us. So I hope you enjoyed that, and tell me if you want any more videos for the ODEs. But the next one that we'll be going on to, once you are happy with all of these that are on this slide, would be partial derivatives. That would be the next section of the Maths 5 that we're going on to. But you have to get good at this one, and you have to get good at everything that's on this slide. Okay, so hopefully that's been okay. So thank you very much, and I'll see you again. Thank you.